Now, we will make an important discussion regarding that. The focal length of the spherical mirror of radius r is given as f is equal to r by 2. That is what I have explained earlier. So if f or r is negative for a concave or converging mirror and positive for convex or a diverging mirror. The power of the mirror is defined as the reciprocal of focal length in meters, or it is 100 over f in centimeters, and the unit of power is diopter. If a thin object of linear size O situated vertically on the axis of the mirror at a distance u from the pole and its image size is I is formed at distance v from the pole, the magnification transverse, that is perpendicular, is defined as. So magnification will be the ratio of image size to the object size or the image distance to the object distance. V is the distance of image, O is the distance of U is the distance of object, I is the size of image, and O is the size of object. So, if the distances are taken towards the left, all distances will be negative, and if the distances are taken towards the right, all distances will be positive. If all the lengths are taken above the optical axis, it will be positive, and below the principal axis will be negative. Negative magnification implies that image is inverted with respect to object, and positive magnification means that image is erect with respect to object. If an object is placed at distance u from the pole of the mirror and its image is formed at distance v from the pole, then 1 over v plus 1 over u will be equal to 1 over f, and this is called the mirror formula. In this formula, to calculate unknown, the known quantities are substituted with proper sign. For concave mirror, the signs will be positive, and for convex mirror, the signs will be negative. Now we come towards the derivation of the mirror formula, that is 1 over u plus 1 over f, 1 over u plus 1 over v equal to 1 over f. Let P is the pole, F principal focus, C center of curvature of concave mirror. Aperture is small, that is curved part is small. PF will be equal to F, then focal length and PC is equal to R, be the radius of curvature of the mirror. Depending on the position of object, the image formed may be real or virtual. All real images are formed on the screen, whereas virtual images, their being name is virtual, they are not on the screen, rather beyond the reflecting surface of the mirror. Now, real image and virtual image, these two things we have to understand. When object is held in front of concave mirror beyond the principal focus, the mirror image formed is real in figure, and object AV is called the perpendicular to the principal axis of the mirror beyond C. A ray of light starting from A and incident on the mirror along AD, parallel to the principal axis, passes through F on deflection from the mirror. Another ray of light incident along AP is reflected along PA dash such that angle APB minus angle I is equal to angle BPA dash is equal to angle R. So APB is equal to angle I and BPA dash will be equal to angle R. That is, I and R are respectively the angle of incidence and angle of reflection. The two reflected rays actually meet at A dash, which is the real image of the point A, and a third ray starting from A and incident on the mirror along AC falls normally on the mirror and retraces its path, meeting the two reflected rays at A dash. So this all we can go through from the figure as described earlier, and from A dash draw A dash B dash perpendicular on the principal axis. Therefore A dash B dash is real inverted image of AB formed by reflection from the concave mirror. So we are taking the two triangles which are supposed to be similar. The ratio of two sides of one triangle must be equal to the ratio of the two sides of other triangle. This principle is adopted. So according to the figure which is described earlier, we find that AB over A dash B dash, that is the size of actual object to the size of that is object taken after the image formation. That will be equal to CB over CB dash. So from the triangle, geometrically we have to prove the things. So CB over CB dash must be equal to PV over PV dash. Now the figure is shown here. The geometry of the figure has already been explained. U is the object distance in the figure. V is the image distance in the figure, and the shaded region is the polished surface. AB is representing an object and A dash B dash is representing an image of object AB. C is the center of curvature and F is the principal focus, and length from P to C is the radius of curvature, and length from P to F will be known as the principal focus. Well, so considering the previous diagram, we are measuring all the distances from P. That is, CB will be equal to PB minus PC and CB dash will be equal to PC minus PB dash. From the third equation, we will get PB minus PC as PB and PC minus PB dash as PB dash. So the ratio will become PB over PB dash, and this is marked as equation 4. Now using the Cartesian sign convention, which I have already discussed, that is, all the numbers which we take towards the left side will be taken as negative and towards the right side of the mirror will be taken as positive. Therefore, according to the diagram indicated earlier, PV is taken as minus U because it is towards the left. PC is taken as minus R, it is also towards the left, and PV dash is taken as minus V, that is distance of image. Now we get from equation 4 the following numbers: minus U plus R divided by minus R plus V, and that is equal to minus U over minus V. However, in all these conventions, R is the radius of curvature, U is the object distance, V is the image distance. So, from equation number 4, we get by cross multiplication, that is plus UR minus UV equal to UV minus VR. Now, if we divide the whole number, that is, we are getting here UR minus UV is equal to UV minus 2R. So, transposing, we will get 2UV is equal to UR plus VR. R will be taken out common. So, 2UV is equal to U plus V. Now, dividing both sides by UVR, we are getting 1 over V plus 1 over U is equal to 2 over R. Now, as R is equal to 2F, so in the above equation for R we will compute 2F, 2 will cancel off, and we will get 1 over F is equal to 1 over U, 1 over V plus 1 over U, which is the required mirror formula.